Hello, welcome to the class on resistors. I'm Laura Lewis. So, learning aims. Explain the relationship between current, voltage and resistance is also known as Ohm's Law. Understand how to calculate the total resistance of resistors added in series, and understand how to calculate the total resistance of resistors added in parallel. Okay, so these are the circuit symbols for resistors. Sometimes we know this is a resistor, but it also be called a fixed resistor, as it has a certain resistance. Example, 10 ohms, it could be 20 ohms, but it is fixed, okay? So it stays the same. As a variable resistor, it could have a variable, so you could sort of turn something and have a resistance between, example, 10 and 100 ohms, example. Yes, that's a fixed resistor and a variable resistor. So they're types of resistors, okay, to start off with. Okay, so let's talk about adding, talk about Ohm's law. So Ohm's law, okay, named after George Ohm. Okay, so Ohm's law in symbol form is V equals I times R. Okay, and here V is for voltage, which is measured in volts, and so that's nice and straightforward. Then you've got I is for current. That's only once a little bit off. Okay, current is measured in amps, and you've got resistance, and it's got a very distinctive unit of the ohm. Okay, resistance. So V equals I R. So what it's saying is that voltage and current, okay, are proportional. So if we wanted to rearrange that and make R the subject, we divide both sides by I. So you get V over I. Okay. So you can say resistance is if current went up, voltage would go down. So if you plotted these, okay, so you've got voltage and voltage and current. Okay, that there is a linear relationship with certain components. If a component with voltage and current is exactly proportional, will be known as an ohmic conductor. Okay, so not all components are ohmic conductors. Okay, so voltage in this graph is proportional to current. The one goes up, the other one goes up. Okay. So in real life, not that many components are ohmic conductors. The lamps and things aren't ohmic conductors. But in an exam, if you see a graph like that, it's an ohmic conductor. Okay. So let's do the nice easy bit. So adding resistors in series. Okay. In series. It's very straightforward. So in a circuit, and we had two resistors. Okay. One's 5 ohms, one's 2 ohms. We just simply add them together. So our total is just R1 plus R2. Okay, so in this case, it's just 5 plus 2 equals 7 ohms. Okay, so you can have any number of resistors in series and you just add them to get the total resistance. Okay, so that's resistors in series. Very, very simple. Okay, but resistors in parallel a little bit more involved. Okay, because in parallel, let's draw a circuit. Let's have one here and another one in parallel. Let's look at the spelling of parallel. All the L's in parallel, I would say. Okay, so you could have your 5 ohm. You could have your 2 ohm there. So this time though, it's all fractional. Okay, so our total equals 1 over R1 plus 1 over R2. 2. Okay, so we don't know what our total is yet. Okay, so this one like that. Okay, 1/5, 1/5 plus 1/2. So 1/5 added to 1/2. Okay, so what you could do there, okay, is find commonality. So if you do, so example that you can put them both over 10. Okay, so a bit of maths going on here. Okay, so something I'm going to say something over 10 and something over 10. There's a maths lesson here. So if it's 1/5, it'll be 2/10. If it's 1/2, it'll be 5/10. So you'll get R 1/R total. Remember, it's still over 1/R total. 2 plus 7/10. Okay, and then flip it round. So to get R total itself, okay, you'd have to flip this through. You're flipping this one, you'll flip this one. So it's 10/7 ohms. Often you leave it as a fraction like that, okay, because yeah, that's something to do on a calculator, okay. So if you had another resistor, okay, down here, okay, it would still be 3 ohms. You'd still add another fraction, 1/R3, okay, like that. So thank you for listening to that. Thank you for listening to this class. Hope to see you in the future one. Thank you. Goodbye.